Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P4, Variant 1, May-June 2018. Let's get started. Adele, Barbara, and Colette share $680 in the ratio 9:7:4. Show that Adele receives $306. The amount Adele receives is equal to her ratio share, which is 9, divided by the total ratio of 9 plus 7 plus 4 times $680. This gives us $306. Calculate the amount that Barbara and Colette each receives. The amount Barbara receives is equal to the ratio share for Barbara, which is 7, divided by the total ratio times $680, which is equal to $238. The amount Colette receives is equal to the ratio share for Colette, which is 4, divided by the total ratio times $680, which is equal to $136. Adele changes her $306 into euros when the exchange rate is €1 equals $1.125. Calculate the number of euros she receives. First, we set up the conversion ratio. When we cross multiply and make x the subject, this is what we have, which is equal to 272 euros. Barbara spends a total of $17.56 on 5 kilograms of apples and 3 kilograms of bananas. Apples cost $2.69 per kilogram. Calculate the cost per kilogram of bananas. The total amount she spends, which is $17.56, is equal to the amount she spends on apples, which is $2.69 times 5, plus the total amount she spends on bananas, which is 3 times the cost per kilogram of bananas, which we are calling B. 2.69 times 5 is 13.45. When we make B the subject, this is what we have, which is equal to 1.37. Colette spends half of her share on clothes and 1/5 of her share on books. Calculate the amount she has left. The amount Colette received was $136. So to get the amount left, we have $136 minus the amount she spends on clothes, which is half of $136, and the amount she spends on books, which is 1/5 of $136. When we type this into the calculator, we get $40.80 rounded to 2 decimal places. The scale drawing shows two boundaries, AB and BC, of a field ABCD. The scale of the drawing is 1 centimeter represents 8 meters. The boundaries CD and AD of the field are each 72 meters long. Work out the length of CD and AD on the scale drawing. First, we set up the conversion ratio based on the given scale conversion. When we cross multiply and make x the subject, this is what we have, which is equal to 9 centimeters. Using a ruler and compasses only, complete accurately the scale drawing of the field. So first, we open up our compass to a width of 9 centimeters, stand at point A and inscribe an arc. Then using the same compass width, we stand at point C and inscribe another arc. The intersection point of the arcs is the position of point D. So all we do now is draw a straight line from point A to point D. Then we draw another straight line from point C to point D to complete the scale drawing of the field. A tree in the field is equidistant from A and B and equidistant from AB and BC. On the scale drawing, construct two lines to find the position of the tree. Use a straight edge and compasses only, and leave in your construction arcs. If the tree is equidistant from A and B, then we need to draw the perpendicular bisector of AB. So using a compass, we stand at point A, then we open up the compass to a width that is more than half the length of AB. Then we inscribe a set of arcs above and below AB. Using the same compass width, we stand at point B and inscribe another set of arcs above and below AB. From here, all we need to do is connect the intersection point of the arcs with a straight line. We've also been told that the tree is equidistant from AB and BC. This means we need to draw the angle bisector of the angle ABC. So first, we stand at point B and inscribe an arc for angle ABC. Then standing at this point, we open the compass to a wider width and inscribe an arc. Using the same width, we stand at the other point and inscribe another arc. From here, all we need to do is draw a straight line from point B that passes through the intersection of the arcs. So now, the position of the tree is at the intersection point of the line bisector and the angle bisector. The price of a house decreased from $82,500 to $77,500. Calculate the percentage decrease. Here is the formula for finding a percentage decrease. In this case, the decrease is $82,500 minus $77,500, and the initial amount is $82,500. When we type this into the calculator, we get 6.06%. Roland invests $12,000 in an account that pays compound interest at a rate of 2.2% per year. Calculate the value of his investment at the end of 6 years. Give your answer correct to the nearest dollar. Here is the formula for compound interest. Big A represents the final value of the investment, which is what we are finding. Small a represents the initial value of the investment, which is $12,000. R is the annual rate, which is 2.2%, and T is the time duration in years for the investment, which is 6. When we type this into the calculator, we get $13,647 rounded to the nearest dollar. Describe fully the single transformation that maps triangle A onto triangle B. When we look at both triangles A and B, we can tell straight away that this is a translation because both triangles have exactly the same size and orientation. The only difference is that they are located on different parts of the grid. So now, all we need to do is find the translation vector. From the illustration, we can tell that the translation vector is -8, 2. And so the full description for the transformation will be translation by the vector -8, 2. Describe fully the single transformation that maps triangle A onto triangle C. When we look at triangle A and triangle C, they do not have the same size. Each of the sides in triangle C is half the corresponding sides in triangle A. This means the transformation is an enlargement by a scale factor of half. We have a positive scale factor for this enlargement because the two triangles have the same orientation. Now we need to find the center of enlargement. To get the center of enlargement, we need to connect at least two corresponding points on both triangles and find their intersection points. When we do this, we get the center of enlargement as -4, 0. And so the full description for the transformation will be enlargement by a scale factor of half about the center, -4, 0. Describe fully the single transformation that maps triangle A onto triangle D. When we look at triangle A and triangle D, they have the same size, but their orientation is different, which means the transformation is either a reflection or a rotation. When we rotate triangle A 90 degrees in the clockwise direction, we get triangle D. For a 90-degree rotation, the way to determine the center of rotation is this. We connect at least two corresponding points on both triangles. Then we need to draw the perpendicular bisectors of these lines. The intersection point of the bisectors is the center of rotation, which in this case is 1, -1. And so the full description for the transformation will be rotation 90 degrees clockwise about the center 1, -1. On the grid, draw the image of triangle A after an enlargement by a scale factor of 2, center 7, 3. First, we need to mark the center of enlargement. Then we need to move each vertex on triangle A such that we are able to reproduce the enlarged image of the triangle. Let's pick point C. To move from the center of enlargement to point C, we move 1 unit to the left and 2 units downwards. And so to pin the new position of point C, we move in the same direction due to the positive scale factor. Since the scale factor is 2, we move twice the number we moved initially. Initially, we moved 1 unit to the left. This means we are going to move 2 units to the left. And instead of moving 2 units downwards, we are going to move 4 units downwards. After repeating the same process for all the vertices on triangle A, we are now able to map out the enlarged image of triangle A. Factorize 2mn plus m squared minus 6n minus 3m. First, we rearrange the terms to have the terms that end in n, which is 2mn minus 6n, and the terms that end with m, which is m squared minus 3m. For the first two terms, when we factor out 2n, we are left with m minus 3. And for the final two terms, when we factor out m, we are left with m minus 3. This can be rewritten as 2n plus m times m minus 3. Factorize 4y squared minus 81. We see that 4y squared and 81 are perfect squares, so we can rewrite the expression as 2y all squared minus 9 squared. By applying the factorization for the difference of two squares, we can rewrite this as 2y plus 9 times 2y minus 9. Factorize t squared minus 6t plus 8. First, we rewrite minus 6t as minus 2t minus 4t. For the first two terms, when we factor out t, we are left with t minus 2. And for the final two terms, when we factor out -4, we are left with t minus 2. This can be rewritten as t minus 4 times t minus 2. Rearrange the formula to make x the subject. K equals 2m minus x over x. First, let's clear the denominator by multiplying both sides by x. This gives us kx equals 2m minus x. When we move all the x terms to one side, this is what we have. When we factor out x, we are left with k plus 1. So now, to leave x standing alone, We divide both sides by k plus 1. This gives us 2m over k plus 1. Solve the simultaneous equations. You must show all your working. First, let's label the given equations. We'll be using the substitution method. So when we make y the subject in equation 2, we have y equals 28 minus 5x. So now we can substitute y into equation 1. This gives us half x minus 3 times 28 minus 5x equals 9. When we expand the brackets and group like terms, this is what we have. And when we make x the subject, we get x equals 6. Now that we have the value of x to be 6, then y is equal to 28 minus 5 times 6, which is equal to negative 2. 3 over m plus 4 minus 4 over m equals 6. Show that this equation can be written as 6m squared plus 25m plus 16 equals 0. When we multiply through the equation by m times m plus 4, this is what we have. When we expand the brackets, negative 4 times m is negative 4m. Negative 4 times 4 is negative 16. 6m times m is 6m squared, and 6m times 4 is 24m. 3m minus 4m is negative m. When we move all the terms to one side of the equation and group like terms, we have 6m squared plus 25m plus 16 equals 0. Solve the equation 6m squared plus 25m plus 16 equals 0. Show all your working and give your answers correct to 2 decimal places. We can apply the quadratic formula to find the values of m. When we apply the quadratic formula to the given equation, this is what we have. Under the square root, 25 squared minus 4 times 6 times 16 is 241. And for the denominator, 2 times 6 is 12. For the first possible value of m, we have negative 0.79 rounded to 2 decimal places. And for the second possible value of m, we have negative 3.38 rounded to 2 decimal places. A solid hemisphere has volume 230 centimeters cubed. Calculate the radius of the hemisphere. The volume of a hemisphere is half the volume of a sphere, which gives us 2 over 3 pi r cubed. When we make r the subject, this is what we have. We've been given the volume of the hemisphere to be 230 centimeters cubed. When we type this into the calculator, we get 4.79 centimeters rounded to 3 significant figures. A solid cylinder with radius 1.6 centimeters is attached to the hemisphere to make a toy. The total volume of the toy is 300 centimeters cubed. Calculate the height of the cylinder. The total volume of the toy is equal to the volume of the hemisphere plus the volume of the cylinder. When we make the volume of the cylinder the subject, this is what we have. The formula for the volume of a cylinder is pi r squared h. We want to find h, so when we make h the subject, this is what we have. The volume of the toy has been given as 300 centimeters cubed, and the volume of the hemisphere is 230 centimeters cubed. We also know the radius of the cylinder is 1.6 centimeters. When we type this into the calculator, we get 8.70 centimeters rounded to 3 significant figures. A mathematically similar toy has volume 19,200 centimeters cubed. Calculate the radius of the cylinder for this toy. If the toys are mathematically similar, then the ratio of their volumes should be equal to the cube of the ratio of their corresponding sides. In this case, we are using the radius. We want to find the radius of the bigger toy. So when we make big R the subject, this is what we have. We've been given the volume of the bigger toy as 19,200 centimeters cubed. From the previous question, we know the volume of the smaller toy is 300 centimeters cubed and its radius is 1.6 centimeters. When we type this into the calculator, we get 6.4 centimeters. The graph of y equals 10 minus 8x squared for x is greater than and equal to negative 1.5 and less than and equal to 1.5 is drawn on the grid. Write down the equation of the line of symmetry of the graph. On the grid, we see that the line of symmetry is the y-axis, which is the same as x equals 0. On the grid opposite, draw the tangent to the curve at the point where x equals 0.5. Find the gradient of this tangent. On the grid, we've drawn the tangent to the graph at x equals 0.5. To be able to estimate the gradient, we need to pick 2 points on this line. Now that we have these 2 points, we can apply the gradient formula. This gives us m equals 8 minus 0 divided by 0.5 minus 1.5, which is equal to negative 8. The table shows some values for y equals x cubed plus 3x plus 4. Complete the table. When we plug in x equals negative 1 into the equation, we have y equals 0. For x equals negative 0.5, we have y equals 2.4. And for x equals 0, we have y equals 4. On the grid opposite, draw the graph of y equals x cubed plus 3x plus 4 for x is greater than and equal to negative 1.5 and less than and equal to 1.5. So on the grid, we plot all the points and connect the points with a smooth line. Show that the values of x where the two curves intersect are the solutions to the equation x cubed plus 8x squared plus 3x minus 6 equals 0. At the point where the two curves intersect, we equate the functions of the two curves. When we move all the terms to one side of the equation, this is what we have. 4 minus 10 is negative 6. By drawing a suitable straight line, solve the equation x cubed plus 5x plus 2 equals 0 for x is greater than and equal to negative 1.5 and less than and equal to 1.5. We need to rewrite this equation to leave the equation of the curve, which is x cubed plus 3x plus 4, on one side of the equation. To do this, we can rewrite 5x as 3x plus 2x and rewrite 2 as 4 minus 2. So now we leave x cubed plus 3x plus 4 on one side of the equation and we move all the other terms to the other side of the equation. This means we need to draw the line y equals negative 2x plus 2 on the grid and find the x coordinate of its intersection point with the curve. So on the grid, we've drawn the line y equals negative 2x plus 2 and we see that at the intersection point, x is negative 0.4. The exterior angle of a regular polygon is x degrees and the interior angle is 8x degrees. Calculate the number of sides of the polygon. Here is the formula for the exterior angle of a regular polygon. We've been given the exterior angle as x, and we are told to find n, which is the number of sides of the polygon. When we make n the subject, this is what we have. To get the value of x, we know that for a regular polygon, the sum of the interior angle and the exterior angle add up to 180 degrees. So we have x plus 8x equals 180. X plus 8x is 9x. When we divide both sides by 9, we have x equals 20. Now that we have the value of x, n would be 360 divided by 20, which is equal to 18. A, B, C, and D are points on the circumference of the circle center O. DOB is a straight line and angle DAC is 58 degrees. Find angle CDB. An angle formed in a semicircle is 90 degrees. These two angles are subtended by chord CD at the circumference of the circle, and so they must be equal. The angles in triangle BCD must add up to 180 degrees. So we have angle CDB plus 90 plus 58 equals 180. 90 plus 58 is 148. When we subtract 148 from both sides, we have 32 degrees. P, Q, and R are points on the circumference of the circle center O. PO is parallel to QR and angle POQ is 48 degrees. Find angle OPR. Chord PQ subtends 48 degrees at the center of the circle and subtends another angle at the circumference of the circle. This angle would be half of 48 degrees, which is 24 degrees. These two are alternate angles. Alternate angles are equal, and so angle OPR is also 24 degrees. The radius of the circle is 5.4 centimeters. Calculate the length of the major arc PQ. Here is the formula for finding arc length. The radius r of the circle has been given as 5.4 centimeters. In the illustration, the major arc PQ has been highlighted. The sector angle for this arc is 360 degrees minus 48 degrees. When we type this into the calculator, we get 29.4 centimeters rounded to 3 significant figures. The probability that it will rain tomorrow is 5/8. If it rains, the probability that Raphael walks to school is 1/6. If it does not rain, the probability that Raphael walks to school is 7/10. Complete the tree diagram. We've been given the probability that it will rain as 5/8. So to get the probability that it will not rain, we subtract 5/8 from 1, which gives us 3/8. If it rains, we've been given the probability that Raphael walks to school to be 1/6. So to get the probability that he does not walk to school, we subtract 1/6 from 1, which gives us 5/6. If it does not rain, we've been given the probability that Raphael walks to school to be 7/10. So to get the probability that he does not walk to school, we subtract 7/10 from 1, which gives us 3/10. Calculate the probability that it will rain tomorrow and Raphael walks to school. This probability is equal to the probability that it rains and the probability that he walks to school. The probability that it rains is 5/8. The probability that he walks to school given that it rains is 1/6. The end becomes times. This gives us 5/48. Calculate the probability that Raphael does not walk to school. There are two scenarios in this case. The probability that it rains and he does not walk to school, or the probability that it does not rain and he does not walk to school. The probability that it rains is 5 over 8. The probability that he does not walk to school given that it rains is 5 over 6. The probability that it does not rain is 3 over 8. The probability that he does not walk to school given that it does not rain is 3 over 10. When we type this into the calculator, we get 19 over 30. In 2017, the membership fee for a sports club was $79.50. This was an increase of 6% on the fee in 2016. Calculate the fee in 2016. If we represent the fee in 2016 with y, then 106% of y is equal to $79.50. When we make y the subject, this is what we have. When we type this into the calculator, we get $75. On one day, the number of members using the exercise machines was 40, correct to the nearest 10. Each member used a machine for 30 minutes, correct to the nearest 5 minutes. Calculate the lower bound for the number of minutes the exercise machines were used on this day. The lower bound for the total number of minutes the machine was used is equal to the lower bound for the number of members who used the machine times the lower bound of the time taken by each member to use the machine. We get the lower bound for the number of members by subtracting 10 over 2 from 40, and we get the lower bound for the time by subtracting 5 over 2 minutes from 30 minutes. When we type this into the calculator, we get 962.5 minutes. On another day, the number of members using the exercise machines, the swimming pool, and the tennis courts is shown on the Venn diagram. Find the number of members using only the tennis courts. The number of members in this region is 16. Find the number of members using the swimming pool. The number of members using the swimming pool is 5 plus 33 plus 4 plus 8, which is equal to 50. A member using the swimming pool is chosen at random. Find the probability that this member also uses the tennis courts and the exercise machines. This probability is equal to the number of members who use the swimming pool and also use the tennis courts and exercise machines, which is 4, divided by the number of people who use the swimming pool, which is 50. Find the number of members who use the tennis courts and the exercise machines or the swimming pool. The number of members in this region is 7 plus 4 plus 8, which is equal to 19. Find the magnitude of vector OB. We've not been given the vector OB. So first, let's find that. OB can be expressed in terms of the other vectors as OA plus AB. OA is 4, 3 and AB is 8, negative 7. To get the resulting vector, we add the corresponding elements in the two vectors. So 4 plus 8 is 12 and 3 plus negative 7 is negative 4. By applying the magnitude of a vector formula, the magnitude of OB is square root of 12 squared plus negative 4 squared. This is equal to 12.6 rounded to 3 significant figures. Find BC. BC can be expressed as BA plus AC. To get BA, we negate AB, so BA would be negative 8, 7. We've already been given AC as negative 3, 6. To get the resulting vector, we add the corresponding elements in the two vectors. So negative 8 plus negative 3 is negative 11, and 7 plus 6 is 13. PQRS is a parallelogram with diagonals PR and SQ intersecting at X. PQ is A and PS is B. Find QX in terms of A and B. Give your answer in its simplest form. QX can be expressed as QP plus PX. PX is half of PR and PR is PQ plus QR. QP is negative A, PQ is A, and QR is B. When we expand the brackets and simplify, we get negative half A plus half B. Calculate m squared. M squared equals m times n. When we multiply two 2 by 2 matrices, the resulting matrix is also a 2 by 2 matrix. To get the element in this position, we multiply the elements in row 1 of the first matrix with the elements in column 1 of the second matrix. So 2 times 2 plus 5 times 1 gives us 9. To get the element in this position, we multiply the elements in row 2 of the first matrix with the elements in column 1 of the second matrix. So 1 times 2 plus 8 times 1 gives us 10. To get the element in this position, we multiply the elements in row 1 of the first matrix with the elements in column 2 of the second matrix. So 2 times 5 plus 5 times 8 gives us 50. To get the element in this position, we multiply the elements in row 2 of the first matrix with the elements in column 2 of the second matrix. So 1 times 5 plus 8 times 8 gives us 69. Calculate the inverse of matrix M. The inverse of matrix M is equal to 1 over the determinant of matrix M times this matrix, which we get by swapping the elements in the major diagonal of matrix M and negating the elements in the minor diagonal. To get the determinant, we subtract the product of the minor diagonal from the product of the major diagonal. 2 times 8 minus 1 times 5 gives us 11. So we have 1 over 11 times 8 negative 1 negative 5 2. Marco is making patterns with gray and white circular mats. The patterns form a sequence. Marco makes a table to show some information about the patterns. Complete the table for pattern 5. From the table, we see that the number of gray mats are increasing by a constant value of 3. So to get the number of gray mats in pattern 5, we add 3 to 15, which gives us 18. For the total number of mats, we see that the differences between the values are increasing by 1. So to get the total number of mats in pattern 5, we add 7 to 21, which gives us 28. Find an expression in terms of n for the number of gray mats in pattern n. Since the number of gray mats are increasing by a constant value, we can use this formula to find the nth term. A1 is the number of gray mats in pattern 1, which is 6, and D is the constant difference, which is 3. When we expand the brackets and simplify, we get 3n plus 3. Marco makes a pattern with 24 gray mats. Find the total number of mats in this pattern. From the table, we see that the pattern number with 24 gray mats is pattern 7. So to get the total number of maths in pattern 7, we first need to add 8 to 28, which gives us 36. Then we add 9 to 36, which gives us 45. Marco needs a total of 6 maths to make the first pattern. He needs a total of 16 maths to make the first 2 patterns. He needs a total of 1 over 6n cubed plus an squared plus bn maths to make the first n patterns. Find the value of a and the value of b. We are using Tn to represent the number of maths to make the first n patterns. Based on this, we know that when n equals 1, Tn is 6. So we have 1 over 6 times 1 cubed plus a times 1 squared plus b times 1 equals 6. When we simplify this, we get 6a plus 6b equals 35, which we have labeled as equation 1. Based on this, we know that when n equals 2, Tn is 16. So we have 1 over 6 times 2 cubed plus a times 2 squared plus b times 2 equals 16. When we simplify this, we get 12a plus 6b equals 44, which we have labeled as equation 2. So now, to get the values of a and b, we need to solve the two equations simultaneously. Let's use the elimination method. Since we have 6b in equation 1 and equation 2, we can easily eliminate b by subtracting equation 1 from equation 2. This gives us 12a minus 6a equals 44 minus 35. 12a minus 6a is 6a and 44 minus 35 is 9. When we divide both sides by 6, we have a equals 3 over 2. To get the value of b, we can plug in the value of a in any of the equations. If we pick equation 1, we have 6 times 3 over 2 plus 6b equals 35. When we make b the subject, we get b equals 13 over 3. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.